Chapter 11, Force and Pressure, Part 3. In previous videos, we have seen there are various kind of forces like electromagnetic forces, magnetic forces, and gravitational forces. These are non-contact forces. Clear? Now, next slide. That means in this video, we will see magnetic force. We have already learned in the class 6 that like poles of two magnets repels each other and like unlocked poles attract each other. The attraction or repulsion between objects can also be seen as another form of pull or push. So, do you have to bring the magnets in the context of observing the force between them? Yes, you have already done the experience in your life. A magnet can exert a force on another magnet without being in contact with it. So the force exerted by the magnet is an example of non-contact force. Similarly, the force exerted by the magnet on a piece of iron is also a non-contact force. That means for magnet, there is no physical contact is required between magnet and any kind of object to push near them. And that's why it is called non-contact force. Second force, we are talking about electrostatic force. What is it? The force exerted by charged body on another charged or uncharged body is known as electrostatic force. That means if the body has some charge like electric charge or magnetic charge, clear, and it is coming to the contact indirectly, that is charged or uncharged body is known as the electrostatic force. This force come into play even when the bodies are not in contact. So this is also called a non-contact force. For example, rubbing comb with your hair. So when you rub your hair with a comb, the charge, opposite charge will be produced in the comb. And when you take near to the any kind of piece of small paper, the paper will be attracted to the comb. That's why it is called non-contact force and it is called electrostatic force. That is due to the electric power. The body is basically, another object is basically coming to the attraction with the another object. So you will learn more about electric charge in chapter number 15. Gravitational force, you are already familiar with this force. You have already learned in the lower classes. So gravitational force is also one kind of the non-contact force. As you know that object things fall towards the earth because it pulls them. And this force is called the force of gravity. And due to the gravity, any object which is there in the outer space, it can automatically come to the earth. That's why it is called non-contact force and this is the gravitational force. This is an attractive force. The force of gravity acts on all objects. That means it does not require any kind of magnet like that. A magnet can only attract the metal, but Earth can attract each and every object which will be there in the gravity area. It may be nails, it may be animal, it may be human, or it may be any kind of object which is living or non-living. The force of gravity acts on all of us all the time without our being aware of it. That means while we are sitting, while we are sleeping, or while we are walking, the gravitational force is applied every time on our body because we are directly contacted with the earth. Water being to flow towards the ground as soon as we open the tap. So water is the reverse flow down due to the force of gravity. So as you know that in your buildings or in your any kind of bungalows, you can see the water tanks are there normally on the top of the floor. So due to the gravity, water will definitely come down. So whenever we open the tap, the water will automatically come. We are not using any kind of mechanical work to that. Clear? Next, the most important point of this chapter, that is called pressure. The next point is, this is the word pressure. So what is pressure? Here Try to push a nail into a wooden plank by its head. Did you succeed? Of course not. And try now to push the nail by the point A. Figure 11.12. Could you do this the time? You can see over here. Clear? So, if the nail is opposite direction, nail would not enter into the wood. But if you maybe if you do the pointed side and just hammering on the top of the head, what will happen? The nail will automatically go into the wood with the help of the pressure of the hammer. Why? That will see. Try cutting the vegetables with a blunt and sharp knife, which is easier. So, sharp knife can easily cut the apple or any kind of vegetables, but the blunt knife cannot cut any kind of vegetables. Clear? Because the sharp knife and the nail, it has some specific pointed area. So that is called surface area. So if the surface area is small, it can easily do the big pressure or the more pressure. Clear? And it can cut it very easily, or it can push it very easily. Sorry, pull it very easily and enter into the wood very easily. So do you get the feeling that the area over which the force is applied, for example, the pointed end of the nail where the force is basically applied and plays a role is making this task easier. So that pointed area of the nail, when we hammering on its edge, it will be easily pulled into the push into the wood. So the surface area is small, the pressure is high, as we can understand in this part. So the force acting on a unit area of a surface is called pressure. So this is the definition of the pressure. So what is pressure? The force acting on a unit area, the specific small area of a surface is called a pressure. This is the equation. Pressure is equal to force divided by area on which it acts. That means we have to apply the force of that specific area, that is called pressure. So note that the area is in the denominator in the above expression. That means we are talking about the above expression. Pressure is equal to force divided by area on which it acts. So the smaller the area, larger the pressure on the surface for the same force. Clear? Here I have already given you the example in the class. That means if your pressure with the help of the pen, if you are pressuring of the opposite side, you will not feel any kind of pain. But in opposite of that, if you are pressuring with the point, that means ball pen point, so you can easily feel the pressure on that. So the area of the pointed end of the nail is the much smaller than the area of this head. That's why the pointed end has the more pressure than the head. So the same force therefore produce a pressure sufficient to push the pointed end of the nail into the wooden plank. Clear? Can you explain now why should bags are provided with the broad straps and not the thread? I have already explained you in the class. That means if the straps are little bit wider, the pressure is little bit lower. Clear? And you can easily carry the bag for the longer period of time. And why tools meant for the cutting and piercing always have the sharp edge? So all these things you can easily understand what is pressure. So if the area is small, the pressure will be high. Like that you can see the example, Potter carrying a heavy load on his head. Clear? So you can see there are some luggages on his head and two bags are there on the shoulder. So the stripes are there on the shoulder, the pressure is basically wider. Clear? So this is one of the example. Okay. Pressure accepted by the liquid and gases. As we have already discussed everything in the class, as you can see there are two tubes, and if one tube has lower water, as you can see over here the water level, and one tube has the higher water, that means this tube has the much pressure than this tube, and you can see the balloon at the end of this that tube, it can be easily inflated very high in comparison of this. So that means this pressure is higher than this pressure. Clear? So water can also accept it pressure on the balloon. Clear? In the second example, you can see if there is a bottle and if you hold of all the side, the water will come out. and it will come with the force because the force is applied by the water from the top. Okay? And another example is also you can see this diagram. In one side, you can just put the tube and the hole and you just put the balloons over there. With the pressure, the balloon will be increasing and it will fill up with the water. So all this example you have already done in your day-to-day life also. And if you have not done, you can do it at home also. It is not harmful, but be careful. Now the last point of this chapter, that is atmospheric pressure. You know that there is air in all around us. This envelope of air is known as the atmosphere. The atmospheric air excited up to many kilometers above the surface of the earth. You know that. That means if we are going to mountain, there also we can feel some atmosphere and we can easily breathe it. The pressure exerted by the air is known as the atmospheric pressure. So what is atmospheric pressure? That means the pressure is exerted by the air, that is called atmospheric pressure. So we know that pressure is force per unit area. So if we imagine a unit area and a very long cylinder standing it filled with air, then the weight of the air in this cylinder is the atmospheric pressure. You can see in this diagram, clear? There is one small tube we have taken and that is the small area at the below. As you can see over here, this is called unit area. For example, 1 inch by 1 inch. So whatever the air in this tube or in this vessel, we can see this is the atmospheric pressure per square inch or per unit area. Clear? So if the area of my head or anybody's head 10 centimeter by 10 centimeter, how much weight of the air would I be carrying on my head? That means if I put any kind of tube, as we have seen previous diagram, so if the same tube, if I put on my head, how much pressure it will applying on my head? That will do calculation. So the weight of the air in the column of the height of the atmospheric area, that is 10 inch by 10 inch, figure 11.19, is as larger as the 1000 kilogram. The pressure, atmospheric pressure is almost like that, 1000 kilogram. How? You can see in this diagram. Clear? If a person has 10 centimeter by 10 centimeter tube and if it is empty, then how much weight the atmospheric pressure has? The weight is around about 1000 kilogram. So this is the pressure of atmospheric on anybody's head. So the reason we are not crushed under this weight, it is that the pressure inside our body is also equal to the atmospheric pressure and they cancel the pressure from the outside. So why we do not feel any kind of pressure of the body? This is most important thing, because our body has also applied the same atmospheric pressure. That's why the atmospheric pressure of the outer side and the atmospheric pressure of our body are equal and opposite. That's why the pressure has been cancelled. That's why we do not feel anything if we put any kind of empty vessel on our head. I hope you understand. Thank you.